For most of human history, worms were thought of as small, harmless, almost insignificant creatures. They burrowed through soil, aerated the earth, and lived unnoticed beneath our feet. But in the fossil record, we find evidence of worms so immense, so powerful, that they turned this simple idea on its head. Imagine standing face to face with a worm taller than a grown man, a predator that lurked beneath ancient seabeds, lying in wait for passing prey. What sounds like a nightmare was in fact real. Known to scientists as the giant ambush worm, this creature dominated its environment hundreds of millions of years ago, using brute force and cunning patience to capture fish, arthropods, and anything unlucky enough to pass overhead. It was not a monster from imagination. It was a product of evolution, preserved in stone and rediscovered only in recent years. The story of this colossal worm begins in the Devonian seas, more than 400 million years ago. This was a time when early fish were diversifying, arthropods like trilobites were abundant, and plants were only beginning to spread across the land. Beneath shallow tropical waters, the seafloor was crowded with activity. Crinoids stretched their feathery arms into the currents. Brachiopods clamped their shells against the flow. Trilobites marched across rippled sand, feeding and shedding their exoskeletons. But below that sand, something far more dangerous lurked. Buried vertically in the sediment were long, muscular predators, segmented like their smaller worm cousins but magnified many times in size. These creatures built burrows as deep as a person is tall. From that hidden chamber, only their armored jaws protruded. And when prey moved overhead, the worm exploded from hiding with blinding speed, dragging the victim down into darkness. We know of these ambush worms not from their bodies, which were soft and rarely fossilized, but from their jaws and burrows. The jaws, known as scolecodonts, are tiny serrated tools of chitin that fossilize readily. They look like miniature pliers, curved and toothed. For decades, they were found scattered in sedimentary rocks, their true owners unknown. Only later did paleontologists realize that these were the mouthparts of polychaete worms, relatives of today's bristleworms. Some of these jaws were enormous, far larger than anything used by living species. Combined with fossil burrows that stretched more than 2 meters into the ancient seabed, the picture became clear. These were worms the size of men, predators unlike anything alive today. Perhaps the most famous example is known as Time's Websteroprion armstrongi asterisk, a Devonian worm discovered in Canada and described in 2017. The fossilized jaws of this creature were the largest ever found from a polychaete worm, suggesting a total body length exceeding 2 meters. To imagine it, one must think of modern bobbit worms, ambush predators that live in tropical oceans today. These worms hide in burrows and snap upward to grab fish with lightning speed, their jaws strong enough to slice prey in half. Now magnify that image by several times, and you approach the monster worms of the Devonian. Their victims would not have stood a chance. The existence of such worms reveals much about ancient ecosystems. They show that predation beneath the seafloor was just as intense as predation above it. In the evolutionary arms race of the Paleozoic, prey had to watch not only for fish, nautiloids, or eurypterids, but also for sudden attacks from below. Fossil burrows called Time's Pinnichnus times record these violent interactions. Many contain signs of prey being dragged down, disturbed sediments frozen in time. The worm itself decayed, but its activity left scars in the stone, a testament to ambush strategies that shaped marine communities. When paleontologists describe such fossils, they often stress their importance as behavioral evidence. Behavior rarely fossilizes. Most of what we know from ancient life comes from bones, shells, and imprints. But burrows, trackways, and bite marks record action, the moment-to-moment struggle for survival. The giant worms of the Devonian tell us that ambush predation was already a perfected art hundreds of millions of years ago. They show us that ecosystems had depth, not just in space, but in strategy. The monster worm was not an accident. It was the result of natural selection exploring every niche, including the deadly one beneath the sand. The anatomy of such a worm is both simple and terrifying. Long segmented body, bristles along the sides for anchoring in sediment, a head armed with curved jaws capable of clamping down with extraordinary force. Unlike vertebrate predators, these worms had no bones, no teeth of enamel. Their weaponry was made of hardened chitin, sharp enough to cut flesh. Their power came not from skeletons but from hydraulics, the pressurized force of body fluids driving sudden extension. One moment hidden, the next exploding upward, jaws wide, prey pulled below. To stand near one in life would have been to sense only the ripple of disturbed sand before being snatched. The terror of surprise was their greatest advantage. What makes these creatures even more haunting is how little we actually know. Because soft tissue rarely preserves, we cannot reconstruct them in detail. We have jaws, burrows, and comparisons to living relatives. The rest is inference. This gives them an aura of mystery. They are predators glimpsed through a glass darkly, real yet partly hidden. We know enough to fear their power, but not enough to fully picture their bodies. For scientists, this mystery is both challenge and thrill. Every new fossil jaw, every new burrow trace, adds a piece to the puzzle, sharpening the outline of the monster worm. The question arises, why did they grow so large? One answer may lie in oxygen levels. During parts of the Paleozoic, oxygen concentrations in the ocean were higher than today. This allowed animals without advanced respiratory systems to achieve larger sizes. It also provided rich prey communities to sustain big predators. Another factor may have been competition. In an ocean with armored trilobites, shelled brachiopods, and agile fish, only the most dramatic strategies could succeed. Ambush predation rewarded size and strength. A bigger worm could drag down bigger prey. Evolution favored giants in the dark. The monster worms eventually vanished. They left behind only jaws and burrows. As ecosystems changed, fish diversified further. Crustaceans became stronger, and new predators appeared. Perhaps the worms could not compete. Perhaps oxygen levels shifted, reducing their potential size. Or perhaps they simply evolved into other forms, leaving behind the extreme giants as dead ends in life's experiment. Whatever the reason, by the later Paleozoic, the reign of worms taller than a man was over. But their traces remain, and those traces whisper of a time when the seafloor itself was dangerous ground. To walk across a Devonian shore and peer into shallow water would have been to see crinoid gardens, trilobite herds, armored fish cruising. The scene would look alien, yet strangely familiar, like an aquarium of forgotten designs. Yet beneath the sand lay something no aquarium today contains, a hidden predator of colossal size. That duality, the visible and the invisible, is what makes these worms so nightmarish. They were not only giants. They were invisible giants until the moment of attack. That is why they haunt our imagination. The discovery of Time's Websteroprion times in Canada was more than just another fossil find. It was a reminder of the importance of patience in paleontology. For decades, Scolecodonts sat in collections, their meaning overlooked. Only when a particularly large set was studied did the true scale of the creature become apparent. This is the rhythm of science. Knowledge accumulates quietly, then leaps forward in revelation. The monster worm emerged from obscurity because someone looked more closely, and in doing so, they gave us a glimpse into a lost world where worms rivaled men in size. To appreciate the scale of such predators, we can compare them to living analogs. The bobbit worm, or Time's Eunice aphroditois asterisk, still lurks in tropical seas. It can grow up to 3 meters long, though most of its body remains buried. It strikes with lightning speed, grasping prey with jaws that snap shut like scissors. Divers who encounter them describe sudden explosions of motion, fish dragged into sand, nothing left but a cloud of sediment. This living species shows us that the behavior of ancient worms was not only possible but still successful today. The difference is that Devonian giants lived in a time of greater ecological openness, when size extremes were more common. They were not outliers. They were apex predators in their domain. The legacy of these worms goes beyond fear. They teach us about the architecture of ecosystems. They show that predation operates on multiple levels, above, on, and beneath the seafloor. They reveal the importance of hidden players in ancient food webs. And they remind us that the fossil record is incomplete not because life was simple, but because much of it was soft and ephemeral. Worms are humble creatures today, but in deep time they ruled with size and stealth. That contrast itself is humbling. It warns us not to judge the past by the present. Imagine standing on a Devonian reef flat, the water lapping at your ankles, small fish dart between corals, trilobites graze. Suddenly, the sand at your feet erupts, a massive worm rising, jaws snapping, body writhing upward taller than you are. The prey is dragged below, the sand closes, silence returns. That scene, repeated countless times across millions of years, left only faint burrows as proof. But with science, we can read those burrows like pages. reconstructing the predator that made them. The monster worm that grew taller than a man was not fantasy. It was fact, preserved in stone, proof that nature's imagination outpaces our own. And so, when we look at the small earthworms in our gardens, we should remember that their lineage once produced giants. When we peer into aquariums and see bristleworms hiding in rock, we should imagine their ancestors looming with jaws that could crush. The story of the monster worm is not only about terror, it is about possibility. It is about the diversity of life's experiments, the boldness of evolution, and the strange, shifting boundaries of what it means to be a predator.